Hello and welcome to another tutorial ProfLearn YouTube channel. In this particular video, we're going to have a discussion how you can be able to work out the specific heat capacity of a substance using electrical method. The first thing that we need to understand, what do we mean? In the first thing, we need to understand what do we mean by the term specific heat capacity. Specific capacity is the amount of thermal energy required to change the temperature of 1 kg of a substance by 1 degree Celsius. So for instance, if you have 1 kg of a substance, the amount of heat that you need to supply for the temperature of the substance to change maybe from 10 degrees Celsius to 11 degrees Celsius. That amount of energy you need to supply to 1 kg of a substance for the temperature to change by 1 degree Celsius is what we call the specific heat capacity. So, in order to use the electrical method, we have the low power supply. We have the ammeter, which is going to give us the current. Yeah. So we have here we have current. And then the ammeter, which is going to give us the current, the voltmeter, which is going to give us the voltage, and the stopwatch is going to enable us know how long was this water heated by this heater that we are having at this particular point. So for us to carry out this experiment, the first thing that we need to do is to close the switch. And then we time how long are we going to heat this water. Now say we are going to heat this water for 30 seconds. And then we record the ammeter and also we record the voltmeter reading. Suppose the current was 1.5 amperes and the voltage is recorded as 12.4. And then now we are going to check what's the temperature change. Before you start the experiment, before you close the switch, you need to record T1, the initial temperature, T1. Now suppose it was room temperature, which is 27 degrees Celsius. After 30 seconds, the temperature now becomes T2, which is maybe 35 degrees Celsius. Then the thing that what we need to do here is to find the change in temperature, which we are going to call change in theta, which is going to be T2 minus T1 in order to get the temperature change, and that will be 35 minus 27 at that point. So if we subtract this, we're going to get our answer is 8 degrees Celsius. That is the temperature change. Then now, in order to work out the specific capacity, there are some formulas that we need to remember. That the thermal energy of a substance, thermal energy of a substance is mass of the substance times the specific heat capacity of that substance times the temperature change. That is how you calculate the thermal energy of a substance. Which means that if we want to calculate the thermal energy, the amount of heat absorbed by this water is the mass of the liquid, if it's water, times the specific capacity of the liquid and times the temperature change that we have gotten at this point. Also, we need to understand that the amount of heat absorbed by water is coming from the electrical heater. So the heater is supplying the heat and the water is absorbing that heat. So heat lost from the heater is absorbed by the water that we are having here. So we are going to say also we need to understand that electrical energy is equals to IVT, meaning that the heater is going to supply the heat, and electrical energy is current times voltage times time. And that's why we need this timer here so that we know how long was the heater powered on. So for that reason, if the heat supplied, heat lost from the heater is the heat that is gained. That's the assumption we're going to make. The assumption in this experiment is that all the heat that is given out is absorbed by the water. So meaning that we can equate these two and say MC, change in data, is equivalent to IVT. Making C the subject, which is the specific heat capacity, we are going to say is IVT divided by M, change in data. So anytime you are working out specific heat capacity of a substance using electrical method, this is the relation we are going to use. Now, with the information that is provided in this particular question, we are going to say therefore that current here is 1.5 amperes. 1.5 times voltage, which is 12.4, divided by the mass of the substance was 0.5 kg. So this 0.5 kg times the temperature change, which is 8 degrees Celsius. So this is going to be equivalent to 8 at this point. So meaning that we are going to put this information in the calculator so that we can be able to get exactly what that is going to give us. And if you're new to ProfLearn YouTube channel, consider subscribing so that anytime we are going to upload further tutorials, you'll be notified. So this is 1.5 times 12.4 divided by 0.5 times 8, and that is equivalent to 0.4. This is equivalent to 4.65. So meaning that this is 4.65 as the specific heat capacity of this. So what is the unit for this? We are going to say this is 4.65 joules per kg per degree Celsius. Per kg per degree Celsius. So basically that's what we are going to get as the specific capacity. So sometimes you may be told to talk of what is it the value, the theoretical value of this, of the specific capacity of this liquid is much less than whatever that we are having at this point. So those are the sources of errors in the experiment. So sources of errors in this experiment, one could be the fact that sometimes some heat is lost in the surrounding. Some heat is lost to the environment, some heat is absorbed by the materials here or the container. And number two, we can talk of error in taking the measurements, reading the temperature wrongly,